we will be continuing with our integration, and specifically we will be doing some examples, some exercises, and we will practice some questions related to integration. Then we will look into how this integration is implemented in the modern calculus. And at the last, we will also see a question from the CIE question paper. So without further ado, let's get started with our topic. Now, we have done a couple of examples, and we have given a couple of homeworks in our last class. So we will basically at first try to do that initially. So I hope you were able to solve those in your homework. If you weren't able to, then it's completely fine. We will be solving it now together. Now, the first one, it was pretty easy, which was f of x is given as 3 of x squared. Now, integrating this, oftentimes you will see integration function is written as I of x or capital F of x, all are right. So it's completely fine. And oftentimes they don't write anything. So you can simply state that I of x or f of x is equals to integration of f of x. That means integrated or indefinite integral of some function is equals to I of x. Okay. Now, placing that 3 of x squared inside, since 3 is a constant, we can bring that 3 outside of the integration function. Now, finally, if you integrate this, we get what? We get the x's power, it's incremented by 1, which is x2 plus 1. And this power also is or becomes the integrating factor to the denominator, which is 2 plus 1 over here. Okay. And remember, our constant is added at the end. So finally, we have what? 3 over 3 x cubed plus c. As this 3 gets cancelled out, and we have our final result of I of x is equals to x cubed plus c. Okay, this is our integrated value, or the indefinite integration of the function 3x squared. Okay, now moving to the next one, we have f of x as 2 by x. Now, again, finding the integrated value of this function with respect to dx, what can be said about this function? Since 2 is a constant, we can bring that 2 in front. We can have 1 over x there. Now try to recognize this concept or this type of this expression. Do you remember from could you recall where have you seen this type of expression previously? If you can't recall, then let me help you. Remember, if we have a equation y equals to ln of x, and if we differentiate it, what happens? The inner function that comes to the denominator, and that inner function gets derived or gets differentiated with respect to x, or simply we differentiates the inner function with respect to dx. So you're differentiating that x gives us what? 1. So that means we are left with 1 over x. That means derivation of ln x is 1 over x. That means anti-derivation of ln of x is, or integration of ln 1 over x is what? Ln of x. That means this should also give us what? A ln x. But remember, there should be a plus c as well added to the front of the equation, because this is the same result which we would have get if there was a 5 added to the initial equation, because integrating that 5, differentiating that 5 gives us a value of 0, which also gives us the same result. So that's generalizing to a constant c. Now if you break the bracket, what do we have? We have 2 ln x ln of x plus 2c. Now this 2c itself is another constant, so we can just simply write this as a whole constant. Okay, because like that doesn't have any effect, because we're writing or representing a constant with some variable, with some like arbitrary or random number, random letter characters. So that's not an issue because that doesn't change the result. Okay, so that's our answer to this expression for integration. Now moving to the next one, which is y equals to cos of x. Okay, so if this y is equal to cos of x, so we are trying to find I of x, which is integration of y with respect to dx. So replacing that y with cos of x give us this expression. We have earlier saw that if our function y is equals to, or function f of x is equals to what? Sine of x, then differentiating or writing f prime, which is actually differentiated term. So f prime of x is equals to what? Cos of x. Similarly, if we have a function f of x as cos of x, that means f prime of x is what? Negative sine of x. Okay. So we use this concept to find the actual result. So see, this is our like we have to find the integrated value. That means consider that this is actually our differentiated value. So we have to go one step in the backward direction. So which of the these are the differentiated value. So which one of them matches with this one? Cos x, isn't it? So that means integrating cos x, or anti-derivation of cos x is what? Sine of x. So we can write simply sine of x here. And remember here, we should also add a constant as well. So this is our final result. So moving on to the next one, we have f of x is equals to 4x cubed minus 2x squared plus 5x. Here we can use the sum rule, sum rule and the power rule to find our actual result. So also here, integration of this expression f of x cubed minus 2x squared plus 5x d, is it 5x? Yeah, 5x dx. And we know that this is all are arithmetically added. That means we can use the sum rule here. So individually doing the differentiation, bringing all the constants in the front of the differentiation, like the integration sign, because it does not have any effect on any of the integration. Finally, if we try to do the calculation, x to the power 3 plus 1, which is 4, so 3 plus 1 right in here, minus 2 to the power x cube divided by 3, because incrementing the power with 1, and 5x to the power 2 over 2. This is a 4, and that's a 4. So 4 gets cancelled out. Finally, we are left with the answer x to the power 4 minus 2 by 3 x cubed plus 5 by 2 x squared. Okay. Hence, this is our final result. Okay. If you were unable to get the didn't get the results, you were confused, then I would urge you to rewatch this part, rewind the video and rewatch this part. Inshallah, you'll be able to get it. Now, moving to the next one, we have the function e of x. Previously, we have seen that if a function y equals to e of x and we differentiate that, we have two portions here, the outer function and the inner function, or the power function here. So the outer function remains itself. It doesn't have any change. So e to the power x remains e to the power x. But the inner function has to get differentiated. So differentiation of that x with respect to x, that gives us e to the power x times differentiation of x is what? That power comes in front. So 1 times x to the power 0, isn't it? Because 1 minus 1 is 0. So anything to the power 0 is what? 1. So that means we are left with final answer of e to the power x. That means integrating this e to the power x should give us what? That initial e to the power x. Okay. So that means I of x of e to the power x, I mean integration of e to the power x with respect to dx gives us e to the power x, but there should be a constant added, because the same result is given if a constant, let's say 100 is added here, because differentiation of 100 is what, or any constant is what, 0, because there is an imaginary x to the power 0 there. Okay, so that's basically it. And we had our final question. Let me see the question first. Is the question given here? Okay, so I might have missed a question here. So I'm just writing the question. It's a different question. Yes, we do have left another question, which is most probably integration of sec square 2 sec square x dx tan x dx. Yeah. So this was like this is to be done, but in order to get this, we have to go through some other concepts as well. So we'll be coming this a bit later, but for now we'll be doing some other maths. So let's do that first. A function is given as 2 sine x plus 3 cos x. Now they're asking us to find the integration of this function. Okay, so integration of this 2 sine of x plus 3 cos x respect to x. So dx is added in the last. Okay, now since they're arithmetically added, that means we can individually do what? Perform our integration on them, isn't it? Now, since these are the constants, we can also like bring them in front, because they are not going to have any like effect on the integration. Now, finally, we have seen in the last slide that when we like find the differentiated value, writing this as y prime, that also represents the same thing, differentiation value. So it gives us cos x. And when we have y equals to cos x, when we differentiate that, we get negative sine of x. Okay, so let's use this formula here. So initially here we have what? A positive sine x. And integration, if integration of negative sine x is what? Cos x, that means we need a negative sign here, isn't it? So for simplicity, if we multiply two negative sign with each other, what do we have? A positive one, isn't it? If we have like multiply -1 with -1, what do we get? +1. That means we can actually introduce two -1s here. Okay, one -1 in the front, and to like eliminate its effect, we will multiply another -1 inside the function, so that we now have a negative sine x here. Plus we have 3, and cos x is here, and the derivation of cos x is simply sine of x. So we don't need to modify this value. Now here, this is -2, and negative sine x, that means integration of negative sine x is what? Cos x. So writing this as cos of x. And we can write a constant here, but we want to include that constant at the very last, because we will have two constants. One is for this part, another is over here, which is 3, and the integration of cos x is what? Sine x plus c. So that means this 2c becomes one constant, isn't it? So writing this as a whole gives us 3 sine x plus a constant c. So this is our final result. So that's how we deal with it. Do we have some other? Yes, we do have some others. So we have some substitution in integration. So we will be integrating like using some substitution rule. Okay. So let's say we have an equation when given f of x is equals to 1 over 2x plus 1. Okay. Now they're asking us to find the integration of this function. So ix, which is integration of 1 over 2x plus 1 with respect to dx. Okay. So that's going fine so far. Now, how do we integrate this term? It looks a bit complex, isn't it? Because 1 over 2x plus 1. We have some new terms at the denominator. Well, the numerator is just simply normal constant 1 is there. But we have some like numerator, so some expression in the denominator, which is something like weird looking. Now, in order to do this integration to make like things much more easier, since here we have what an arithmetic operation going on in the denominator. So 2x plus 1, that means two different terms that there. One is 2x, another is a 1. So 2x plus 1. So that means like we do know to deal with a single variable, like to deal with a single term is much more simpler and easier than to deal with two different or like multiple different terms, isn't it? So that's the same thing we are going to do, but we would try to actually like bring this or make this term a single term. Okay, so how do you do that? So let's try that at first. Let's say we have a variable, a new expression. Okay, let's represent what is in the denominator with a single variable. Let's say we have an equation u equals to 2x plus 1. Okay, we are just like writing this denominator expression as a new equation. So we have some u equals to x plus 1. Now let's differentiate this u with respect to x. Like simply think it in this way. If we had y here, instead of u, we had y here. Then what would have we have like done to find the differentiation of this y? So dy by dx is equals to simply doing the differentiation, isn't it? So just doing the same thing, just changing the variable name from y to u, you will get like the differentiated value to be du by dx equals to what? 2 times x to the power 1 is here. So that means what? This 1 will come in front and the power of x will reduce to what? 0. So that means we would have simply a 2 here. And since 1 is a constant and we have an imaginary x to the power 0 here, and differentiating that should give us an expression of 0. That means that 1 becomes actually 0 because 1 times 0 is equals to 0. So we can just simply say that du by dx is basically equals to what? 2. Now subjecting or just stating what subjecting dx gives us what? Dx equals to 2 by, du by 2. Just bear with me for this portion. You might be thinking, what am I doing even? But try to bear with me. So we have dx equals to du by 2. Okay. With some like just like doing cross multiplication, bringing this dx to the right hand side and bringing the 2 to the left hand side. So dx actually becomes what? Dx gets multiplied with this 2, isn't it? This dx gets multiplied with this 2. And if we bring the 2 to the left hand side, then what happens? That 2, like du gets divided with 2, isn't it? 2 gets to the denominator. So that's what actually happened. Now, what did we do here and why are we like having a constant with this? What we would try to do is change this term to the values or variables of u. How do we do this? See that this 2x plus 1 can be represented with a single u, isn't it? So 2x could be represented as u. So writing, instead of 2x plus 1, we will write here u. But we have a dx here. Now how to deal with this? Because we have an expression of u here. And we need to integrate this with respect to u rather than x, like to get a valid answer. But we have a dx here. Now how do we do that? That's what we did here. We found the differentiated value of that u with respect to x. We subjected dx. Now we will substitute this dx with the value of du here. So dx is equal to what? Du by d2. So simply multiply du by dt here. So we are substituting that the value of dx here with du by, sorry, not d2, simply 2. So dx is equals to du by 2, and we are substituting this 2x plus 1 with the expression u. Now it is a bit easier. We have a 2 here. That 2 is a constant, so we can bring that 2 at the front of the integration sign, and we are finally left with what? 1 over u du, isn't it? Now, see one thing. Can you try to guess what type of expression is this 1 over u? We've just done a math in the last slide, maybe 2 question earlier. So this is the expression we get when we different something with respect to ln, isn't it? Because u to the power, what is here? Like u has a power of what? 1, because u to the power 1 is equals to 1. I mean, sorry, u to the power 1 is equals to actually u, isn't it? So we don't need to write that power here, power of 1 here, because that power of 1 represents a single unit, and we have a single unit here. Now, we do know that differentiating ln of x gives us what? 1 over x. That means integrated 1 over x should give us ln of x. Similarly, if we differentiate ln of u with respect to u, we should get 1 over u. Similarly, if we integrate that, we should get a ln of u. So that's the same thing here. We are integrating this 1 over u. We should get a ln of u. So ln of u here, not x, rather u here. And we have a imaginary, I mean a constant. Okay. Now breaking the bracket should give us half ln of u, and we have a half of c, which is actually basically like another constant. So we can write a simple new constant here, c. Okay. You can do for simplicity that write k here, okay, or c1 here as the constant, previous constant. And after multiplying k with half, that becomes a new constant. So we can write that half of k is actually c. So we are replacing that half of k with a c here. Okay, so that's basically our integration is done here. But wait, we are still not done. Why? Because they asked us to find the function or integration value with respect to x. But what have we found here? Expression, integrated expression with respect to u. That means we have to get rid of this u and introduce some x here. But how do we do that? Simply place this expression here. Substitute this u with the 2x plus 1. It's the same thing. The substitution we are doing here. That should give us a value of 1 over 2 ln of. Remember, we can only place inside a ln a positive value. That means we need a modulus sign. So 2x plus 1. This modulus sign means that all values inside this ln x should be positive, like ensuring that all values are positive here. So that's our basic answer of this expression. That means integration of this expression 1 over 2x plus 1 is basically 1 over 2 ln of 2x plus 1 plus c. Now, if you differentiate this value, you should get the same answer. Let's try it. So if we have 1 over 2 ln of 2x plus 1 plus c, if we differentiate this constant remains constant, like just simply differentiating this 1 over 2. The inside function comes to the bottom, 2x plus 1. And at the top, we have this, like the inner function gets differentiated. So we have 2. Then differentiation of x is what? 1. So 2 times 1 is 1, like 2. And this positive 1, that constant, differentiating that constant gives us what? 0. So we don't need to include any number here. We can simply write 2 here. And also we have a c constant here. Differentiating that constant also gives us a value of what? 0. Now, all are in a multiplication format. This 2 gets cancelled out with this 2. Finally, we are left with what? 1 over 2x plus 1. See, we can return back to the initial expression. So that is actually our answer here. I hope that makes sense. Now, let's do some other maths. Just a minute, I'm searching in the book, like what type of maths could be done. why do we use integration? We have learned, or we have seen in the last lecture, that it is basically to find the polar expression. But integration means what? Finding the area under a curve, isn't it? Now that means if we want to, like, let's at first consider this. If we want to find the area of a rectangle, a rectangular box, what do we need? What is the area, like, formula for area? Length into breadth, length into width. That means what? In order to find area, we need two values, length and width, and we need to multiply them, isn't it? So that's how we actually find the area. Similarly, in integration, okay, before that, we need some length and width, isn't it, to find the area. Okay, now if, let's say, this is a curve and this is a point, okay, let's say we have an imaginary rectangle here. What do we need to find the area? We need the length and the width of this rectangle. Now, how do we find this length? We can see that this length is somewhere here, which is, let's say, the coordinate of 2. And this, and let's say this coordinate is somewhere here. Also, not also, but at a point of, let's say, 1, okay? Now, these are the points at the, like, these are like one of the points, isn't it? Let's say for this length, the coordinate, the end, like one of the end coordinate is at 2. Now we also need to find the initial coordinate, isn't it? We can see the initial coordinate here is what? 0. Here we have a 0 here, isn't it? The coordinate, initial coordinate is what? 0. So that means the distance or the length of this line is what? 2. Plus 2 minus 0 is what? 2. Similarly, the difference between these 2 points is what? 1 minus 0 is what? 1. So that means we also know we do know the length, and we do know the width as well. If that's the case, we can simply use the formula equals to what? 2 times 1, we get the answer, isn't it? Okay. Now let's say if let's say if this is a curve, I mean this is a graph we're drawing. Let's say this is a rectangle here. Okay. Let's say the starting coordinate is at 1, the ending coordinate is at 3. And similarly here, this is at, let's say, 1, this is at 2. Now your task is to, or what do you need to do is to find the area. But before finding the area, you need what? You need length and width. Now how do you find length and width? Here length and widths are not given, rather some coordinates are given, or the points at which the specific position of the rectangle lies. Now I would urge you to pause the video here and try it by yourself to find the area or the length and the width at first. Tell me the L and W values. I mean, the length and the width value at first. If you weren't able to find, it's completely fine. We will be doing it together. But if you're able to find, then really, that's good. Very good. Now, notice here, this is the length, isn't it? This is the length here. Notice one thing. Now this length actually doesn't start from the origin of the 0 point of x. Rather, it starts from 1, continues to 3. That means the length is what? This is our x2, this is our x1. So our length is x2 minus x1. That is actually 3 minus 1 equals 2. Now see, similarly, our width is what? This is our width, and this also does not start from the origin value. I mean the 0 value of y. So that means we need to find the width here, and the y coordinates are y1 and y2. Similarly, w is what? y2 minus y1. That means this is actually 2 minus 1, which is actually 1. Therefore, our area is what? Length into width, which is 2 times 1 equals to 2. So that's our area here given. Now the let's say if this is our rectangle given here, but we don't have a complete rectangle here. Rather, we have a, let's say, straight line here. Okay, let's do this at first. Let's say this is our triangle given. Let's make things easier, like a bit easier for now as well. This is a triangle. Let's say this coordinate is at 2 and this coordinate is also at 2. This point is also at 2. That means x coordinate is like this x coordinate is 2 and that x coordinate, y coordinate is what? 2. Now, in order to find this area of this like rectangle, well, I mean, sorry, triangle, what do we need to do? We have a formula half into base into height, isn't it? So what is the base here? This is the base here. Now, do you know the base length? Yes, sort of. We can see that this, like the triangle starts from origin. I mean, the 0 value of x to the and continues to the like the coordinate of x where it is 2. So that means b is what? B is equals to 2 minus 0, which is equals to 2. Similarly, the height value is here 2 minus 0, which is equals to 2. So we can simply like place this inside this expression or the equation and we can get the answer as 2. That's our area. Now, instead of this, let's say we have, like we were not given this like expressions here. Okay, we were not given the, like, I mean, this, we are not given these values here. Rather, what we are given is a straight line equation, which is y equals to x given here. Okay, that means this straight line, I mean, this line, let's try another part. This straight line is known as the, let's say, the equation, like the straight line, and this equation is given as y equals to x. Now they are asking us to find the area under this curve for like this region, and they have said that this point is given as, let's say, 2. They haven't given us any y value. Then how should we find? And you could say that let's substitute the value of 2 here in this expression. So we could get the y corresponding y value. That means y equals 2. That means corresponding this 2, the y value is what? 2. From this equation we can get, yes, that's one of the way we can do it. But when things get a bit more complex, let's say we have this sort of equation, this sort of curves, okay, then how do you find, let's say, this specific region's area? In that moment, that's not going to work because we don't know the like formula for those regions. Let's say if this is a curve, we don't have the formula to find the area of those curves. But one thing we know is the integration of this curve represents, if we have these 2 points there, and if we can find the integration and the value in like between the two points, 2 coordinates, we can get the area under this curve. So let's try this with this expression or this equation, straight line equation at first. Let's clear up the board. So we have been given, let's say, the equation as y equals to x, and they are asking us to find the area under this curve. And the x coordinate is here given 2. So how do we deal with this? Now, in order to do this, we need to find what? The integration of this expression. Let's write, instead of y, this as I of x, or we can also write this as just simply area. We can say area is equals to integration of this expression y, which is actually x with respect to dx. Now comes the part. Remember, I used to talk about limits. Here is the limits, because we can find integration, but we need to find the area which is between 2 specific points, isn't it? Because our area has what we have just seen in the rectangular part, that it has a x2 and a x1. In between that x2 and x1, we have the length. In between that y2 and y1, we have that like width. That means it is between 2 values. Similarly, see here we have, like, we need two x values here. One of the values given as x of 2. Now, what is the other value of x? Like, from where do the length starts? It starts from what? X equals to 0, and it continues until what? X to like x equals to 2. That means it starts from 0 and continues till 2. So we are going to start from 0. So the starting value is placed at the bottom of the integration sign, at the bottom right corner of the integration sign, and the 2 is represented on the top right corner of this integration sign. Okay, so these are the two positions where we place the limit from. That means it starts from this position and continues till that position. Okay, if that's the case, then we can simply just find, like, do the different, like, integration first. So integrating this x gives us what? The power of x increases, so 1 plus 1 divided by 1 plus 1. Okay, now one thing consider, we are not going to write any constant here and any c here. We are just going to give square brackets or square braces, and we're going to place the limit at the very right of the, very right of the square brackets. Okay, we are not going to include any constant here. We will be coming back to that, like why we won't actually introduce any constant there, but for now we will just consider this integration value. Now, writing x squared by 2 here, we have these two limits there. Now the next step is to simply place these two ones, like this upper limit once inside this expression. That should give us what? 2 square by 2. And place the bottom limit to this expression again, adding to 0 square by 2, and subtract them. I mean the bigger value minus the smaller value. I mean the upper limit's value minus the lower limit's value. The upper limit is 2, the upper limit's value is this one, and the lower limit is 0, and the lower limit is this one. Now writing this 2 gets cancelled out. We have a 2 here. That means 2 from this portion, and we have a 0 here. 2 minus 0 is what? A 2. So that's basically our answer. And we have seen that